A chemical equation describes what happens in a chemical reaction. The equation identifies the reactants, that are starting materials, and products, that are resulting substances, the formulae of the participants, the phases of the participants, namely solid, liquid or gaseous, and the amount of each substance. Balancing a chemical equation refers to establishing the mathematical relationship between the quantity of reactants and products. There are essentially three steps to the process. Step 1. Write the unbalanced equation. Step 2. Balance the equation. Step 3. Indicate the states of matter of the reactants and products. Let us discuss these steps in detail. Step 1. Write the unbalanced equation. We cannot write a reaction until we know what is it going to form. To write unbalanced equation, we must know reactants and products in the chemical reaction. Chemical formulae of reactants are listed on the left-hand side of the equation. Products are listed on the right-hand side of the equation. Reactants and products are separated by putting an arrow between them to show the direction of the reaction. Reactions at equilibrium will have arrows facing both directions. Step 2. Balance the equation. Draw boxes around all the chemical formulae. You are drawing those boxes so that you will be sure not to mess around with the formulae to balance the equation. Make an element inventory. That is, note the number of atoms both before and after the reaction. Write numbers in front of each of the boxes until the inventory for each element is the same both before and after the reaction. Step 3. Indicate the states of matter of the reactants and products. Use G for gaseous substances, use S for solids, L for liquids, AQ for species in solution in water. You can also use up arrow for gases and down arrow for precipitates. Let us see an example of writing a balanced chemical equation with the help of these steps. Write the chemical reaction when silver nitrate reacts with hydrogen sulfide. Step 1. Write the unbalanced equation. We must know that when silver nitrate reacts with hydrogen sulfide, it forms hydrogen nitrate and silver sulfide as the precipitate. Let us write reactants, that is silver nitrate and hydrogen sulfide, on the left hand side. Write the products, that are hydrogen nitrate and silver sulfide, on the right hand side. Separate the reactants and products by putting an arrow between them to indicate the direction of the reaction. Step 2. Balance the equation. Draw boxes around all the chemical formulae. You are drawing boxes so that you will be sure not to mess around with the formulae to balance the equation. Make an element inventory. That is, note the number of atoms both before and after the reaction. On the reactant side, Ag has 1 atom, N has 1 atom. Since it is O3, there are 3 atoms of O. Since it is H2, there are 2 atoms of H and 1 atom of S. On the product side, H has 1 atom, N has 1 atom. Since it is O3, there are 3 atoms of O. Since it is Ag2, there are 2 atoms of Ag and 1 atom of S. Thus, there is imbalance for 2 elements, namely Ag and H. Let us try to balance Ag first. Since there are 2 atoms of silver after the reaction, let us put 2 before AgNO3. Since we have 2 molecules of AgNO3, we have 2 atoms of Ag, 2 atoms of N, and 6 atoms of O. If we compare the number of atoms for each element, we see that there are 2 atoms of N in the reactants and 1 atom of N in the products. Similarly, there are 6 atoms of O in reactants and 3 atoms of O in products. Also, there are 2 atoms of H in reactants and 1 atom of H in products. All other elements have equal number of atoms in reactants and products. Thus, there is imbalance for 3 elements, namely N, O, and H. It can also be noticed that count for these elements before the reaction is twice that after the reaction. Hence, let us put 2 before HNO3. Let us again make an element inventory, that is, note the number of atoms both before and after the reaction. It is seen that all the elements have equal number of atoms in reactants and products. Yahoo! Since the count of atoms for all elements before and after the reaction is equal, the reaction is balanced now. But our job is not yet over. Step 3. Indicate the states of matter of the reactants and products. Since black silver sulfide gets deposited after the reaction, we have to indicate it by a down arrow. Thus, finally the reaction looks like as given below. 2AgNO3 plus H2S give 2HNO3 plus Ag2S as a precipitate.